Okay, so I'm going to hit record and start sharing the screen. All right, so I was done with 10.1 and 10.2 actually. I'll get started with some of 10.3, but I won't go that far. We're not going to do any polar graphs today. I'll start the polar graphs on Tuesday. All right, so after you take the test, then you'll want to start going to that website that had the polar graph paper. So I'll start graphing polar graphs on Tuesday, but I won't do any polar graphs today, but I'll introduce the topic today for a while, okay? So I'll lecture for a while on polar coordinates. I'll save the graphs for Tuesday. So have your polar graph paper ready Tuesday. So how many do I need? For the whole semester, maybe 15 to 20, okay? And we're gonna use a lot of them up very quickly and then it'll slow down. So even on Tuesday, we might end up doing, I don't know, maybe as many as 10 even, between 5 and 10, I would say. So you want that many on Tuesday, okay? All right, so I'll lecture a while, then I'll stop, let you ask questions. If there aren't any questions, then we'll break and go straight to the test, okay? And this is what you're supposed to turn in. Some of you have already turned it in. I'll get that, or I've already gotten that, and that's fine, okay? So again, I'm not bothering with the attendance. You can, I'll take attendance when the test starts, but just go ahead and take notes now or wait for the recording later, but obviously don't look at it too carefully because we have the test coming up. Okay, so polar coordinates. 10.3, page 658. All right, so it's another way of declaring points on an XY plane. We are, of course, comfortable with the XY coordinate system, but there's another system that's often useful called the polar coordinate system, where instead of X comma Y, you have something called R comma theta, okay? So let me show you the picture that's best for this. So figure 5, it's on page 659. So let's take a look at this picture right here. Okay, so what you have is a first quadrant point. It doesn't matter what quadrant you're in, but for teaching purposes, it's nice to start off in the first quadrant. You can pick any other quadrant. Okay, so we're comfortable with X and Y, right? X, Y, this distance here is X, this distance here is Y. In fact, we use that quite a bit. Okay, but what if instead I had an R, which is the distance away from the origin, and theta, the distance, the angle that is made with the positive x-axis in standard position, the normal theta, right? Where this direction is considered 0, this way is positive, this way is negative, right? So we could have any point, so let's take this point here, it has an x and y, but I could also label that point as how far am I away from the origin, r, like radius, and theta. Okay, so do you agree if I have any point, let's say a point up here, I can name it by how far am I away from the origin and what is the angle that it makes with the positive x-axis. Okay, so that's going to be r comma theta. So instead of x comma y, we have r comma theta. And there are some nice relationships here. It looks like the cosine of theta is adjacent over hypotenuse, so x over r. Sine of theta is opposite over hypotenuse, so that's y over r. Okay, do a little bit of multiplication, and we have these formulas. So x is equal to r cosine theta, y is equal to r sine theta. Okay, you can put that on your next cheat sheet. Okay, if we were meeting in person, yes, I would make you memorize it. Okay, we have a Pythagorean relation, of course, x squared plus y squared equals r squared. Okay, and we can also say that tangent of theta is opposite over adjacent. Tangent of theta is y over x. Okay, and we see that on the next page. R squared is equal to x squared plus y squared. Tangent of theta is y over x. Okay, so now when we label points, like they put 2 comma pi over 3, they say that it's polar, but you can't tell right away necessarily whether it's polar or rectangular. Okay, so if that's the case, I will put a superscript. So I'll show you my notation. I will put R and P, R for rectangular, or sometimes called Cartesian. So you say, what's Cartesian coordinate system? It's the XY system that you're used to. I'll superscript with a P for polar. So X comma Y for rectangular, R comma theta for polar, as the case may be. Okay. So here's my version of it. Same picture. Okay, now, in polar coordinates, very, very technically, the origin is now called the pole, P-O-L-E. It's the pole. But I don't mind if you still say origin. So X, Y, R, theta. X comma Y in rectangular coordinates, R comma theta in polar coordinates. Okay, one thing you may notice right away is that X comma Y in rectangular coordinates is unique. I mean, there's only one. Okay. So if you give me a point, right? Like here's a dot. There's only one X and Y you can come up with, right? You just measure how far is it this way and how far is it this way. But R comma theta is not unique. Okay. So for instance, if I say 5 comma pi over 6 in polar coordinates, I could also call that 5 comma 13 pi over 6, because if I go to pi over 6, I go all the way around the circle, that's 2 pi. And if I add another pi over 6, I land at 13 pi over 6. So there's more than one way to label a point in polar coordinates. I could also go backwards. I could go backwards and say 5 comma negative 11 pi over 6 in polar coordinates. And look at this. We're also going to say negative 5, 7 pi over 6. Okay. Now, pi over 6 and 7 pi over 6 are 180 degrees apart. Okay, so if you have one point over here, you could aim 180 degrees apart if your R is negative. So it's like you're walking backwards. Okay, so if you were to go to 7 pi over 6, right, you angle out to here. So you're ready to walk out this way. But then there's a negative. Okay, then I back up 5 units and I also land in the same spot. Okay, so you can have a negative value for R. It just means you're walking backwards from the pole. Okay, so when you write X comma Y, it's unique, but R comma theta is not unique. We'll have to use that further down the line. Okay. All right, so I'll show you some problems. Again, the problems are from my book, the 7th edition. I noticed some of these match, some of them don't match, but again, you're still learning stuff. So the main thing is that you're learning stuff. Okay, so in polar coordinates, plot the point 2 comma pi over 3. Right? So you go to 60 degrees, standard position, go out here. Right? So you go this way. So I know it's 60 degrees, pi over 3. And now how far out do I walk? 2 units. So 1, 2. These are concentric circles. Concentric circles means they have the same center. Okay. The polar graph paper that I'm giving you has 14 concentric circles. And again, I have a requirement that you must use that paper for teaching purposes and to make it easier for me and to see if you know the material based on how I'm teaching you. Okay. So you go to 60 degrees and walk out 2. Okay. That's my 1A. Now they also ask for 2 other ways to label the same point. Okay. See if I can show you the directions here quickly. Okay, so find 2 other pairs of polar coordinates, one with R greater than 0 and one with R less than 0. Okay. All right, so 2 pi over 3. I could go around another 360 degrees, or 2 pi. So if I add 2 pi to pi over 3, I have 7 pi over 3. So I could also say 2 comma 7 pi over 3, which is going all the way around the circle once, 2 pi, and then go another pi over 3, so 2 comma 7 pi over 3. Now, if I want a negative, I go 180 degrees apart, or pi radians. That's over here. Okay, so over here is 4 pi over 3. So I could say negative 2 comma 4 pi over 3, which means you aim at 4 pi over 3. I'm ready to go this direction, so to speak. But then you say to yourself, oh, there's a negative. So that means I walk backwards and I land also at the same spot. Okay. So that's that one. Okay, 1B, again, my 1B. 1 comma negative 3 pi over 4. So negative 3 pi over 4, I go this way, right? So positive 3 pi over 4 lands me here. So negative 3 pi over 4 lands me here. So I go out to negative 3 pi over 4, walk out 1 unit. Okay, label another way with a positive r and a negative r. So positive r would be this angle here, right? So instead of going backwards 3 pi over 4, I can go forwards here, which would be 1 comma 5 pi over 4. And then with a negative, of course, well, I can go 180 degrees apart from that. That'd be over here, pi over 4, okay, and say r is negative 1. So negative 1 comma pi over 4 also labels the same point, because that means you go out to 45 degrees. Okay, here we are, 45 degrees. I'm ready to walk in this direction, but I have a negative 1, so that means I walk backwards, and I also land at the same spot. Okay. All right, then my 3a, to give you a point in polar coordinates, change it to rectangular coordinates. Okay, so 1 comma pi, so pi radians is over here, and you just walk out 1 unit. Okay, now you could use the formula. The formulas are x equals r cosine theta, y equals r sine theta, but I don't need that here. This is on a unit circle, 1 unit. So what is that point in regular x and y? That's negative 1, 0, right? So no big deal there. Okay, but what about something like 3c, negative 2 comma 3 pi over 4? Okay, so 3 pi over 4 is over here. And I walk backwards 2. So I land over here. So where's here? I would rather use a positive r than a negative r. So I will label this as 2 comma negative pi over 4. Okay. Or you could also say 2 comma 7 pi over 4. Okay. But I'll just stick to this. All right, so how do I change it to x and y? I use the formulas. Well, the book showed it too, but I don't have it here anyway. But x equals r cosine theta, y equals r sine theta from before. Okay, so r is 2. So 2 cosine of negative pi over 4. Cosine of negative pi over 4 is radical 2 over 2. So these 2's cancel out, radical 2. Y equals r sine of theta. 2 sine of negative pi over 4 is 2 times negative radical 2 over 2, which is negative radical 2. Okay, so in rectangular coordinates, so polar coordinates, negative 2 comma 3 pi over 4. That was 3 pi over 4, walk backwards 2. Okay. Again, if I'm going to use the formula, I want a positive r. So that's the same as 2 comma negative pi over 4. Polar, polar. But there's only one way I can label this in rectangular coordinates. That would be radical 2, negative radical 2. Okay, so this point is radical 2 to the right, about 1.4, and then radical 2 down. That's the only way you can label it in rectangular coordinates, right? Because there's only one way you can label the point in rectangular coordinates, but there's many ways that you can label a point in polar coordinates. Okay. All right, so here's my 5a, 2 comma negative 2 in rectangular coordinates. What is it in polar coordinates? Okay, so change rectangular to polar. So 2, negative 2. So that looks like, because this is 2, this is 2, this is a 45-degree reference angle. So I can go all the way here with theta being 7 pi over 4. Okay, or you could say negative pi over 4, but they wanted an angle between 0 and 2 pi. So 7 pi over 4. And I can use the Pythagorean theorem, but it's a 45, 45, 90 triangle. So if this is 2, this is 2, the radius is 2 radical 2. You know that. Or you can do your a squared plus b squared equals c squared stuff. But if you have a 45, 45, 90 triangle, you can use the property that the hypotenuse is square root of 2 times either side. So 2 radical 2. So how do I label this point? 2 radical 2 comma 7 pi over 4 in polar coordinates. Okay. If you want a negative r, then I go 180 degrees off, which is 3 pi over 4, and say negative 2 radical 2. So negative 2 radical 2, 3 pi over 4 in polar coordinates. Okay. Okay, then 5b, again, my 5b, -1, radical 3 in rectangular coordinates. Okay, so that's 1 to the left and radical 3 up, second quadrant. Okay, so first find the radius. So 1 squared plus radical 3 squared equals r squared, right? 1 radical 3. 1 plus 3 equals r squared. R squared equals 4. R is plus or minus 2. Let me start with a positive 2. Okay, so this is 2. That means this is 30 degrees. Okay, you might remember from high school geometry, if you have a 30, 60, 90 triangle, the side opposite the 30-degree angle is half the hypotenuse. Okay, so if this is 1, this is 2, this is 30 degrees. Or you could also say the sine of 30 degrees is a half. Okay, so that means this angle here is also 30 degrees. From high school geometry, these are called alternate interior angles. Okay, so they're congruent. That's 30, that's 30, this is 90. So in standard position, this is 120 degrees, or 2 pi over 3. Okay, so 2 pi over 3 is right here. Okay, another way to think of 2 pi over 3 is, 360 is 2 pi. That's what I meant by this. 360 is 2 pi. Divide this by 3, you get 120. So divide this by 3, 2 pi over 3. Okay, so this is 2 comma 2 pi over 3. I go to 2 pi over 3, and I walk out 2 units. Okay, to have a negative r, but still have an angle between 0 and 2 pi, I add pi to 2 pi over 3. So 2 pi over 3 plus pi is 5 pi over 3, and -2 is my r. Okay, so this is r comma theta. Okay, one thing you may notice right away, when we were doing x comma y, it actually didn't matter which comes first, but usually we do x and then y, right? You could do y and then x. Like suppose this said 2, 3, right? You would go 2 to the right, 3 up. But there's nothing wrong with going 3 up and then 2 to the right. But when you do r theta, can you see what you have to do first? If it's r theta, you have to start with the angle. So even though it's written as r comma theta, like 2 comma 2 pi over 3, you must start with 2 pi over 3 and then walk out 2. Okay? And stop and think about it. What if you start off with 2, right? You say, okay, I'm going to walk 2. Well, how do you know which way to go, right? Am I going 2 that way or that way or that way, right? Or imagine here, should I go that way or that way, 2 that way? So r theta, you always start with the theta first. You move to an angle, and then once I know the direction, then I can walk, 1 or 2 or whatever, okay? All right, so that's that. Now, I should be done in hopefully a few minutes. Okay, so we have some questions involving sketch the region in a plane consisting of the points whose polar coordinates satisfy the given conditions. Okay, so what do these things look like? All right, so I think these match for the most part. R is greater than or equal to 1. Okay, and by the way, yeah, I'm just saying the word pole. Pole is the origin in polar coordinates. Okay, so R equals 1. Think radius equals 1. That's that. It's a solid circle because I'm including it. If I didn't have that line underneath it, it would be a dotted circle. And then R bigger than 1, so I just shade everything outside. So I'm shading the entire XY plane except for stuff inside the unit circle. Okay. All right, number 9 said R is greater than or equal to 0. Well, that's always true. And then theta between pi over 4 and 3 pi over 4. Okay, so I just draw pi over 4 here, 3 pi over 4 here. There are lines underneath each of these, so they are solid. If I didn't have the line underneath it, they'd be dotted. And then I shade everything here. And that includes the origin or the pole because R is greater than or equal to 0. If I didn't have that line underneath it, I would actually have an open circle there. Okay, and yeah, about R greater than or equal to 0. Yeah, we don't want R negative there. Otherwise, we'd have to walk backwards and include stuff over here. So we want to leave that out in this particular case. Okay, then 11, R is between 2 and 3, not counting 2, not counting 3. And just check the book. Yeah, I think this time it does match. And theta is between 5 pi over 3 and 7 pi over 3. And this time it's inclusive. Okay, 5 pi over 3 is over here. 2 pi is 6 pi over 3. Here's 7 pi over 3. So 7 pi over 3 is coterminal, lands you in the same spot as pi over 3. Okay, there is a line underneath here and a line underneath here. So it's solid here, but these are dotted circles. I'm not including r equals 2 or r equals 3. So at r equals 2, I have a dotted circle, and r equals 3, a dotted circle. Okay, and then I shade this region right over here. Okay, so r equals 2 dotted here because of that and that, but solid here and solid here because of that and that. So it looks like this. Okay. All right, then we have some questions about identify the curve by finding a Cartesian equation for the curve. See, what's Cartesian? It's x and y. See, these are r and theta. Change it to x and y. How do I do that? I have these formulas, right? R squared equals x squared plus y squared. Tangent of theta is y over x if you need it. And r, so these guys, x equals r cosine theta, y equals r sine theta. Okay. So they told me r squared equals 5. Well, r squared is x squared plus y squared. So there it is. X squared plus y squared equals 5. What does that look like? That looks like a circle, center of the origin, with a radius of radical 5. Okay, so that's what r squared equals 5 gives me. Okay, 17, there's a trick to it. It starts off with r equals 2 cosine theta. The trick for that one is to multiply both sides by r. Because that way you get r squared equals 2r cosine theta. And there's r cosine theta. R cosine theta happens to be x. So x squared plus y squared equals 2x. Okay, what does that look like? I'll do a little bit of algebra here. Subtract 2x. X squared minus 2x plus y squared equals 0. I complete the square, right? Half of -2 is -1. Squared is 1. Complete the square. Add 1 in red to both sides. That way you can factor this into x minus 1 squared plus y squared equals 1. Okay, so there it is. This is a circle centered at 1, 0 with a radius of 1. So that's what this looks like. Circle centered at 1, 0, radius is 1. Okay, 19, r squared cosine 2 theta equals 1. And let me check. Yeah, that does match. That one also matches. So for that one, I'm going to use the identity. Cosine of 2 theta is cosine squared theta minus sine squared of theta. Okay, so that's an identity from trig. Distribute r squared cosine squared theta minus r squared sine squared theta equals 1. Write this as r cosine theta squared minus r sine theta squared. That happens to be the formula for x. So it's x squared minus, that's the formula for y. So it's x squared minus y squared equals 1. Okay, that shape is a hyperbola. We'll come back a little bit more in section 5 to the so-called conic sections, the circle, the ellipse, the parabola, the hyperbola. Don't write any of that down right now. Okay, but that ends up looking something like this. Okay, let's see. Find a polar equation. Okay, so this is rectangular equation, x and y. Change it to r and theta. So just use the formula, right? Anytime I see x, it's r cosine theta. Anytime I see y, it's r sine theta. So y equals 2, which incidentally, we know what it looks like. It's a horizontal line. Change y to r sine theta equals 2. Okay, and we'll do more of this later, but generally R is a function of theta. So we're going to try to isolate R, solve for R. So how do you solve for R? Just divide by sine theta. So R is 2 over sine theta. Sine theta in the denominator is cosecant in the numerator. So R equals 2 cosecant theta. So believe it or not, R equals 2 cosecant theta is the same graph as Y equals 2. It's just harder to recognize that, of course, from here. Okay, then the last one, and then I'm done. 23. Y equals 1 plus 3x, which incidentally is a line. We know it looks like a line. Y equals mx plus b. Okay, so y, r sine theta, x, r cosine theta. So r sine theta equals 1 plus 3r cosine theta. All right, solve for r. So subtract 3r cosine theta on both sides. R sine theta minus 3r cosine theta equals 1. Factor out the r. We normally try to solve for r. It's usually r as a function of theta, just like y is normally a function of x. So r parentheses sine theta minus 3 cosine theta equals 1. And just divide both sides by that. So r equals 1 over sine theta minus 3 cosine theta. Okay, so in polar coordinates, this crazy thing is the same as that. So this is a straight line. I know it doesn't look like it, but it is. Okay, so y equals 1 plus 3x. In polar coordinates, r equals 1 over sine theta minus 3 cosine theta. Okay, so I'm going to stop there and show you what's up after that. Okay, so 10.3, I've done everything up to here and here. And next time, Tuesday, these are sketching the curve with a given polar equation. Okay, so we will start using our polar graph paper, and I'll show you how to graph these things next time. So again, by next Tuesday, have your polar graph paper ready. And it must be that graph paper that I sent you before from mathbits.com. Okay, and I gave you the link to that, I believe. If you lost it or you can't find it, just send me an email and I can get it to you again. Okay, so otherwise I am done. So let me stop the share and check the chat. Okay, so can I show? So yes, for the exam, I will show you here, but I also, I want to be able to catch everybody. So I will send it via the Canvas announcements, but I'll also show it here. Okay, when is the exam starting? Well, same thing, as I said last time, whenever you're done asking questions. Okay, so now it's question and answer time for the test, which can last anywhere from 0 up until 8:25 at the latest. So I'll take any questions now that you might have. So you can either unmute yourselves or send it in the chat. Well, we need to be graphing slope fields. You have to be ready to graph slope fields. Okay, but otherwise the question is slope fields on the test? I can't answer that, of course, as you know. It's eligible to be on the test. Okay, 9.3, number 7. Okay, and I'll wait a little longer because I don't want to keep bouncing back and forth. So if anybody wants to ask questions, it'll be faster if you all ask it right now, rather than, okay, I finish that, then I got to switch back and switch back and forth. Okay, so somebody asked for 9.37. Anybody else want to ask me something? Well, I turn the book. So if you wait until I share the screen, then I have to, look back, so that wastes time, which of course means less time for you in the test. Okay, 9.37, 9.317. Okay. Nine point 315. Okay, if you have a surface area, if you're rotating about the y-axis, then it's 2 pi x. It's the other letter. Okay, so if you spin about the x-axis, multiply by 2 pi y. If you spin about the y-axis, 2 pi x. Okay, so I see some problems in the chat already. All right, so I'll share the screen and do that. I can no longer see the chat until I get out of that mode. Okay, 9.3, I have several questions. 9.3, number 7. D theta dt equals t secant theta over theta e to the t squared. Okay, so multiplied by dt, theta goes up, secant theta goes down, dt goes up. So I have theta d theta over secant theta equals t e to the negative t squared dt. You multiply by theta, divide by secant theta, t e to the negative t squared dt. Okay, secant on the bottom means cosine on top. Theta secant theta d theta equals t e to the negative t squared dt. Okay, I believe I did do this problem earlier, but you integrate by parts here. I1, I2. So this one is parts. U equals theta. Oops, this should be cosine. Cosine theta. So U equals theta. dV equals cosine theta d theta. du equals d theta. V equals sine theta. I1 is uv theta sine theta minus the integral of v du sine theta d theta. So theta sine theta, integral of sine is negative cosine, so plus cosine theta plus C1. I2, integral of t e to the negative t squared dt multiplied by negative 2 and negative 1/2. U equals negative t squared. Du equals negative 2t dt. I2 is negative 1/2 integral of e to the u du, which is negative 1/2 e to the u plus c2, which is negative 1/2 e to the negative t squared plus c2. Then I just set I1 equal to I2, and that's it. So theta sine theta plus cosine theta equals negative 1/2 e to the negative t squared plus c. And you cannot solve for theta, so stop. Okay, 9.315. Okay, I believe I did that one also, so I may not want to go that far with that one. X ln x equals y, 1 plus radical 3 plus y squared dy dx, y prime, y of 1 equals 1. Okay, since I did this problem, it requires a little bit of time, but since I did it, I'm just going to have to say, refer back to your previous notes, unless you can prove to me I did not do it. But I'm pretty sure I did this one. This one you do by parts. This one you break it into y plus y radical 3 plus y squared. This would be dy. This would be dx. Right? Put dx over here. So that's an easy one by parts. I'm pretty sure I did that. So look back on your notes for that one. So that's all I wanted to do with that one. 17. Okay, I don't think I did this one. Y prime tangent of x equals a plus y. Y of pi over 3 equals a x is between 0 and pi over 2. Okay, so dy dx tangent x equals a plus y. A is a constant. 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 A is a cons See if I did that right. Okay, so multiply by dx, divide by that, dy over a plus y equals divide by cotangent x, or divide by tangent x. Okay, which is the same thing as multiplying by cotangent x. Okay, so integral of dy over a plus y equals integral. Okay, so you can either memorize the formula for cotangent, but in case you don't, it's cosine over sine, and then do a u substitution. I1, I2, I1 is ln absolute a plus y plus c1. I2, u equals sine x, du equals cosine x dx. So I2 is the integral of du over u, which is ln absolute u plus c2, or ln absolute value of sine x plus c2. Okay, so that equals that. Put the c's together. So I have ln absolute a plus y equals ln absolute sine x plus c. Exponentiate e absolute a plus y equals c. Remember, I can think of this as e to the ln sine x times e to the c. E to the c is c. So I have c absolute sine x, and we said you can drop the bars. A plus y equals c sine x. Okay, and then I use the fact that y of pi over 3 equals a. Oh, I should solve here. So y equals c sine x minus a. Okay, so y of pi over 3 equals a. A goes here. C sine of pi over 3 minus a. Add a, I get 2a. Sine of 60 degrees is radical 3 over 2. So multiplied by 2 over radical 3. 2 over radical 3. Gone, 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 gone. C is equal to 4a over radical 3, it looks like. Okay, so just put that back over here. So final answer, y is 4a over radical 3 sine x minus a, like that. Okay, so I've caught up with that. Let me check the chat again. Okay, so yeah, so if you revolve about the x-axis for surface area, 2 pi y, and the other way around for the other. Do I actually want to show you that? If it takes me too long, sorry, I don't have it, but we did go over that. The section on surface area. Okay. Here, right? So revolve about the x-axis, 2 pi y ds. Revolve about the y-axis, 2 pi x ds. Right? You can put it on your cheat sheet, even now. Okay, I think I'm caught up with the chat. All right, so anybody else, please? What time is it? 7 minutes to 8, roughly? Anybody else, please? Okay, then we'll stop. Let me get the actual time. I've got 7:51. Okay, so we'll break until 8:01-ish. Okay, so during that time, you can break as normal. I will, during that time, send you over Canvas announcements, the exam, and I'll also project it on the screen here. Okay, yeah, there's no reason to record anymore, so I'll stop the recording and we'll break. In the meantime, get your materials together, get your cheat sheet together, and so on. Okay, so break time.